Okay, so for JavaScript, there's a topic called control statements, or sometimes control structures. And those are typically if-then-else statements, and then loops, like a for loop, a while loop, what they also call a do-while loop, and then function calls. Okay, so an if statement. What is an if statement? Well, we've talked earlier in the semester where we have lines of code that run, no matter what they're going to run. So if we say variable x equals 3, that line is going to run for sure. Variable y equals 4, that's going to run for sure. Z equals 5, that's going to run for sure. And then we're going to make a message. We're going to print out a message, and we're going to say the message, variable message equals the range is the string. Now we're going to have some statements. I just want to take this away for a second. I might say message equals message plus x. I might put a 3, add that on to the message. But maybe I won't. It's going to depend. So with an if statement, we could put a Boolean statement in front of it, something that's either true or false. And if it's true, this line of code will run. But if it's not true, then this line of code will not run. So this line of code may or may not run. These ones run. These will definitely run because we just said run this line of code. But if we say if and then put in a statement that's either true or false, then this line of code will only run if this statement is true. So for example, x is equal to 3. Is this statement true? X is less than 4. Is that a true statement? If x is 3, is x less than 4? Right? So that would be a true statement. So this line of code will run. And I'll say message equals, whatever the message is, I'm going to put a 3 in front of it and then a space. Okay? Now the next statement says if y, this means not, an exclamation point. If y is not, double equals means you're asking a question on the equal, you're not assigning something. So if y is not equal to 4, then I'm going to run this line of code. I'm going to say message equals message plus the value of y. So would this statement be true? Is y not equal to 4? Is that a true statement? Y not equal to 4. So y is equal to 4, so this is a false statement. Therefore, this line of code will not run. Then another if statement, if z is equal to 5, well, it means equal to 5, so this will be a true statement. Therefore, this line of code will run. So the message equals message plus 5. So what would the output of this code be? It would say the range is, this one was true, this one was false, this one was true. What would it say? Range is 3 and 5, right? No 4. 4 would not be. Okay. So now, if we knew we were going to go through a series of variables like x, y, and z, if we could do them using an index, it could make things simpler for us. So for example, suppose we had a variable start equals 3 and stop equals 20. Okay? And we're going to print out a message. We're going to print out a message saying the range is, so we're printing out a range of numbers. So if we said the range is, and let's say we wanted to go through every one of the numbers between 3 and 20, but not say, have 17 lines of code adding each number on. We'd like to be able to run the same line of code over and over and over. For the range between 3 and 20, we can do that using a for loop. So a for loop means we're going to have, there's 3 parts to a for loop. There's an initializing condition, a Boolean that's either true or false, and then another step that runs after the loop is finished, and hopefully this will make the loop eventually stop running. As long as the Boolean statement is true, the loop will run, and when it gets to the bottom, we come back up to the top and we run this line again, and then check if the Boolean statement is true. So in this case, we're going to let the variable I, the index, it's popular to use the letter I in computer science. We'll have it start at the value 3, and as long as the value is less than or equal to the stopping value, as long as it's less than or equal to 20, we're going to keep repeating this line over and over and over, as long as the statement is true. After we do what's in this loop, we're going to run this line of code, I equals I plus 1. So this is just shorthand for I equals I plus 1. Okay, so what would the output message in this case be? So the message will be the range is semicolon, and then it's going to keep concatenating an I with a space after it. And I is going to go for the range, start all the way to stop. So this would print out the range is 3, 4, 5, 6, 7, all the way up to 20. Okay? Okay. Another type of loop, very, very similar, and I've colored in red what changed from the for loop. So if you remember in the for loop we just discussed a second ago, we initialize the loop by having the variable I set to the start value, which is 3. Then, every time we run the loop, we keep checking if the condition is true. And if the condition is true, we run the loop again. So now we're checking, is I less than or equal to stop? Same condition we had before in the for loop. If so, we go through the loop. And when the loop is finally done, in the for loop, we had, at the top of it, we had the line of code that runs at the end of the loop. When we're doing a while loop, we actually just type the line of code here at the bottom. So the stuff in red is just a reorganization of the for loop, and now this is effectively the same loop. Do you see any advantage or disadvantage to doing this way? Well, so one advantage maybe down the road is the stuff we're doing to initialize might be more than one line of code. Remember, so just look at what's in red, and I'll go back one to the for loop. So basically, here's the first line before the loop. Here's the Boolean statement that's either true or false, and here's what we do at the end of the loop. So with a for loop, I'm forced to put them up top. I only have room for one line of code here, and I only have room for one line of code here. When I do the while loop, everything that's done initially, before the loop starts, I kind of have freedom now. I could do one line of code, it could be many lines of code. I have a little more freedom. And also, what happens at the end of the loop, I kind of have the freedom, because I'm required as the programmer, to put that code in the loop, instead of on the for statement. I could put it in the middle as opposed to the end. So this just gives me a little bit more freedom to while. But more freedom means more error proneness. So yeah, just some comparisons between a for loop and a while loop. Is for loops require 3 lines of code in the header, the initializing statement, the Boolean statement, which is either true or false, and if it's true, the loop runs. If it's false, it doesn't. And then one statement that runs after the loop has completed before we go up and determine if we should run the loop again. The while loop has more freedom. The initialization is done prior to the loop, and there's no limit on how much initializing, how many lines of code I can use to initialize the loop. The Boolean statement is exactly the same as the for statement, the for loop. So it's something that's either true or false. If it's true, the loop runs. If it's false, the loop does not run. And then in that loop, I can have 0 to n, as many statements as I want that will help terminate the loop. Okay. So here's an example of an if statement mixed in with a while loop. So we have the range going, let's say, from 3 to 20. We say the range is start is equal to I. And I'm saying while I'm less than stop, so it's no longer less than or equal to. So this will now range between 3 and 19. And then I threw in an additional if statement. Now remember we said an if statement is something you put in front of a line of code to determine whether it may or may not run. If what's in the if statement is true, the line runs, but if it's false, it doesn't run. So the line of code is optional. So if the value of I is greater than 5 and the value is less than 15, then we will add it to the output message. And then once again in the while loop, I'm adding 1 to it to eventually make the loop stop. So what would the output of this message be? This would say the range is, I'm going from 3 to, as long as I'm less than stop, as long as I'm less than 20, so I'm going to range from 3 to 19. But I'm not putting every number in. I have a second condition you have to meet. You have to be greater than 5 and less than 15. So what would this output? Any ideas?
Between 6 and 14?
Yeah, it's going to say the range is between 6 and 4. It's going to say 6, 7, 8, 9, 10, all the way up to 14. Okay. So like I say, we had the loop went through 3 through 19, but then this if statement filtered out a few more cases. Okay. Then they have a loop called a do while. And the part that's in red is the only thing that moved since the last loop. So basically you have your initialization before you go and loop through the task you're doing. And then we say do, and the loop starts here and ends here. So we go through this code, and again, it's greater than 5, less than 15. So it's going to only add the range between 6 and 14. And then at the end of the loop, we check the Boolean expression. So the only difference between a while loop and a do while loop is we check if the statement is true after we go through the loop as opposed to before. Only difference. So really, what's the difference between a do while versus a while? The do while, the code in the loop is guaranteed to run at least one time. It will run whether this statement is true or not. It runs, then when it gets to the bottom, it says, okay, is it true? And if so, it'll run again. And as long as this is true, it'll run an extra time and an extra time. So this is guaranteed to run once. That's the only difference. So a while loop could possibly never run. Go back to a while loop. If, for example, let's say start was 25 and stop was 20. So if I was 25, it would immediately, this statement would be immediately false, and the code in the loop would never run ever. Whereas in the do while, it's guaranteed to run at least once. Because we do this, we run through the code and then we check, is this true? And if it's true, we'll run again. Okay, so now we get into the issue of what if, oh wait, hold on. Let's just go over the flow chart of each of the two loops. The do while loop is exactly like the while loop, except that the loop is guaranteed to run at least once. Okay, so for example, we check the condition in a while loop. We check if the condition is true or false. If it's true, we run the body of the loop and we come up and check again. So it's check, run the code, check, run the code. The do while loop is the code comes first and the check comes second. So you run the code at least once, and then you check if it's true and you run again. You run again. So the only difference is you guarantee the code in the loop will run at least one time. Okay. So one of the big dangers to loops is you could have either a programming error or a runtime error where the loop may run forever, may not stop. So here's a silly example of a programming error. For variable I equals 1, then we're going to check, is I greater than 0? And if I is greater than 0, we will run the loop again. So then we go through our code, and at the end of the code, we increment I by 1. So now I becomes 2. And we say, is I greater than 0? And 2 is greater than 0, so it runs again. and then it becomes 3, and it is still greater than 0. So this condition, I being greater than 0, will always be true because this line of code that is supposed to eventually cause it to become false will never become false. It'll just keep staying true forever. This loop would run forever. So here's an example of a programming error. Now a runtime error is when you coded it in such a way that it would eventually terminate, but maybe some outside data is causing something to change. So the loop could continue running forever. So in either case, an infinite loop is always going to be a problem because if your code goes into an infinite loop, it'll never finish. And if you've ever been on a computer and then like the screen goes gray, and then it says, what's the error message you get when the screen goes gray? It says this program is not responding. Would you like to terminate it? You ever get that? Right. So that's sometimes it's the code goes into a deadlock, which you might learn about in your operating systems class, and sometimes you're in an infinite loop. And it just looks like it's running and it's not getting it. So for example, Apple computers, where are they located again?
Cupertino.
Cupertino, okay. So out in California, Northern California, their headquarters has a road that goes around it, and then there's parking all around the road. And the name of this road, they asked the town if they could rename the road Infinite Loop. So there's never a situation when an infinite loop is a good thing. So it's always a little strange when they name that. A lot of computer programmers say, why would you name a street around your headquarters after an error? That kind of jinxed the company, I guess. But anyway, so they call the road Infinite Loop because if you got on the road and just kept driving, you could drive forever. Okay. All right. So then back to the control statement and if-then statement. So we said that an if statement is we check if a condition is true or not, and if it's true, we run the line of code. But if it's not true, we skip it. So it makes code optional. Well, we could also find ourselves in a situation where if the condition is true, we might want to do one thing, and if the condition is false, we might want to do a different thing. So that's an if-then-else situation. So for example, when we talked earlier in the semester, we talked about we could ask the client machine what day of the week is it. So let's say the client machine came back and told us the day is 3. And if you remember the day of the week number, it's like Sunday is 0, Monday is 1, so 3 would be Wednesday, right? So suppose we asked the client machine what day is today, it would tell us 3 if we did it on a Wednesday. So we might say if the day of the week is 1 or bigger and 5 or smaller, meaning 1, 2, 3, 4, or 5. If it's one of those days, then our output message is going to be weekday. Today is a weekday. But if it's not one of those days, then it's the weekend, and then we print out the message. Right? Now, do you see any possible, error or so this is either going to tell you, based on this number, it's going to tell you whether it's a weekday or a weekend, right? And if the number is between 1 and 5, it's going to say weekday. If it's any other number, it's going to say it's the weekend, any other number. Now 0 and 6, which would be Sunday, 0 is Sunday and 6 is Saturday, that would be fine. But what if it was some other number? Suppose, for example, we ask the client machine, what day of the week is it? And it gives us the number numerically. We're counting on it to give a number between 0 and 6, right? What if there's some error that the service is not working? They gave us -2 or something as the day of the week. What would this code tell us the output is? Right, so in other words, if the day of the week was something not between 0 and 6, or some other number, 10, -20, this code would tell us what? So this code is basically telling us that this code is basically telling us that it's a weekday. Any other number, if it's between 0 and 5, it's a weekday. Any other number, it would be a weekend. Okay, so it would be nicer if we had something a little more broken out, you know. If it's between 1 and 5, it's a weekday. If it's 0 or 6, it's the weekend. And if it's anything else, we don't know what it is. Invalid day, something to that effect. Okay. Okay, so now the other thing so basically the control of your program is whenever something other than going one line after another, anytime that is disturbed. So when we call a function, we've talked about functions in previous classes. When we call a function, we're basically asking the computer to go perform a task, and when it's done performing that task, return back to where we came from. So suppose we said the day of the week is 3, which would make it a Wednesday. And then we said our output message is, we call this function part of the week. What part of the week? Is it the weekday or the weekend? And then we print out the message. Well, this function, part of week, we defined it here. We said function, part of week, and it takes in as input a variable. We'll use the letter D as a place to record the variable. So the number 3 gets copied into this function, and we're asking, what day of the week is 3? Hopefully it'll answer that it's a weekday. And so now we have our if statement, just like the one from before, but we're using the variable D. If it's greater than or equal to 1 and less than or equal to 5, that means it's a weekday, then a variable called M, which is going to be our message, M is weekday. Else, M is weekend, and then we return M. So M is just a message, a temporary variable to put the message in, and we return it back to this thing, which gives it to the variable MSG. And then we print out the message from MSG. So this is if you're going to do this task over and over and over, rather than write the code over and over and over, like this. Instead of writing this code 100 times, we could write it once as a function, and then just simply every time we need it, we just call the function. It's going to keep doing the same steps over and over, so let's write it as a function. Okay, and then back to what we had before when we had a lot of complicated, you know, that if statement started getting complicated, the if then else. It's not like two conditions. Either it's a weekday or it must be the weekend. It's actually possible, especially if you're asking some other computer for some information, you don't know what they're going to come back with. So you have to be a little defensive and say if they give you garbage back, you have to say this is something invalid. So we can have a more complicated if-then-else statement that goes something like this. So suppose the day of the week came back as a -3. That should never happen, but if we ask the client machine, the clock on your computer, actually a lot of the clocks here at the school are off, right? Like by 15 minutes or so, right? So anyway, if you ask the client machine, your machine, what day of the week it is, if for some reason it gave a number that's not between 0 and 6, gave some other number, we don't want to say today is Wednesday when obviously it's not working well. So suppose our day of the week came back as -3. Well, that's not a legitimate day of the week. So what we can do is we can say switch day of the week. We could say in case it's a 0 or a 6, that's a strange syntax, but you list all your cases. It's kind of like saying if it's 0 or it's 6, then the message becomes the weekend, and then we break out of here. We don't go looking at other cases. If the case is 1 or 2 or 3 or 4 or 5, then the message is the weekend, and again we break out of it. If we made it all the way down and never got anything ever became true, then we'll have by default, it'll be an invalid day. So now we've handled every case, and then we can print out the message. So if they gave us a day like 25, which is not a day of the week, there's no 25th day of the week, then we're going to say, well, it's not 0, it's not 6, so it wasn't the weekend. It's not 1, 2, 3, 4, or 5. It's not a weekday. It must be an invalid day. And we'll say the day of the week is invalid. Okay, so functions in JavaScript, the way you create them is you use the word function. You give it a name, you make up a name. You could put as many parameters, things that you're passing in to perform a calculation. And then you write your code. So when JavaScript reaches the return statement, a function will stop executing. And also when it reaches the end. If you don't have a return statement, when it reaches the end, then it's like all the task you're trying to do are finished. If the function is invoked from a statement, JavaScript will return to the statement after the code was invoked. And often the function computes a return value and it will be returned back to the colon. So, is our function. So, in this example, we ran through some code and then we said return n. So basically what this thing is doing is it's generating a message and the message will be sent back to whoever called it. So n will get returned to the variable that's here and run. If we didn't have a return and it just stopped, it would just stop and come back to here. It wouldn't return any information, but it would keep going. So the control of your program, it went from this line to this line. It jumped to here, went through here, and then jumped back and kept going. Okay. Okay. So now that we're a little bit more comfortable with functions, we're going to just revisit the difference between a for loop and a while loop. So remember, a for loop I think it's a less error-prone loop than a while loop. Because the for loop makes you state your initial condition, the Boolean expression, the thing that's either true or false. True makes the loop run, false means it doesn't run. And then one statement that hopefully, if you keep running it over and over, the Boolean will eventually become false, so the loop will eventually stop. You won't be in an infinite loop. And it's kind of, so you have one line to initialize and one line to make some kind of a change that will cause the loop to eventually stop. Well, you lose a lot of freedom, and in a while loop, you can actually call functions as your Boolean. So for example, suppose we had a file that we're gathering up information from the internet, and we're stuffing it into a file. And we keep doing this over and over and over. Well, once the file is eventually full, let's say we said, once the file hits 1 megabyte, then we're going to stop it. We're going to stop adding to it. We'll ship that file and we'll start a new file. So we might have a while statement that says while, and then we'll call a function. And the function could be file not full. So you give it a file name, and then this function will check the file, see how big it is, and if it's not full, then we will call another function that says put more stuff in the file. If the file is full, whatever this function decides is a full file, the loop will stop. And then we could ship the file and then start a new file if you want. So the for loop says one initialize and control variable. You have a Boolean statement that is initially true and usually becomes false. And then a control statement that makes the Boolean eventually become false. In this case, the loop may not run at all because it's a while loop. And the Boolean function is in fact, the Boolean statement is in fact a call to a function. So, yep, okay. Okay, so any questions about control statements?